I'm Jonathon Poling. I'm a principal consultant with SecureWorks. When I saw the agenda come out, I immediately looked for where Hal was presenting, and I saw that I was going right before him, and I was like, oh, thank God. Hal is a hard act to follow. He's done a lot for the Linux community. He likes to say he's successful, by standing on the shoulders of giants, and I like to say I'm partially successful by standing on the shoulder of a giant who stands on the shoulders of giants. So thank you, Hal, for a lot of the work that you've done. I'm already off script. I'm like a minute into this thing. Be cool. Play it cool. All right, here we go. Let's jump right in. So I am a huge proponent of the treat yourself model. All right? So what we're going to do today is give you a short little overview of the AWS security model, which is a little bit of a boring thing, but is rather important to understanding why we care about this stuff in general. We'll go through a few items on how to set yourself up for success, right, by logging, monitoring, environment prep. And then once you're set up for success, you can then, oh my God, that was weak. You've had a break. You should have your second cup of coffee in you by now. Targeted response, log collection, system data analysis, right? So you want to be prepared for this stuff, right? You don't want to go in and, we have customers coming to us and say, something happened and we're not prepared at all, right? And it's even worse in the cloud. So let's start with the shared responsibility model. So you can see there's a clear delineation here, right? So when we talk about incident response in AWS or with clients, they say, well, why should I care? Like Amazon secures the cloud. Isn't it secure by default? They're responsible for security of the cloud, right? But we're not operating of the cloud, we're operating in the cloud, right? So we are responsible for everything basically above infrastructure, right? And this is super important, right? So they provide the infrastructure as a service. And this is really a critical model to follow, which builds kind of into the why. So why should we care? Why should we care about doing incident response in AWS? Amazon's awesome. They do everything amazingly well. They offer so many things. They give you so many tools to do so many awesome things. But they're really set up there to help facilitate you do response. They say, here's the tools. We'll help facilitate you do security, but we don't do security for you. So why would we care about this? Why do we care about doing incident response, and why would we have a presentation on this? Isn't this all taken care of? No, right? So does anyone here use OneLogin? Their companies at an enterprise level. All right, so this is relatively commonplace. But from the recent OneLogin attack, right? So attackers came in through the AWS infrastructure, and the attack started at 2 a.m. PST, right? So they're not doing this in the middle of the day when everyone's at work, right? Created several instances to do reconnaissance. They detected it, and they saw that within minutes they were able to shut it down and determine that the keys were stolen. So within a couple minutes they were able to instrument themselves and see what was going on. But how many people here operate in AWS at all? 4, 5. I don't want to ask this. How many people operate in Azure? Okay, good. I want to make sure we weren't outnumbered. So how many of you can say, yeah, if an attack happened at 2 a.m., I would be able to detect it within minutes? Can anyone here detect an attack at all? Hey, 1. All right. So these things need to be thinking about, right? There's a lot of stuff that goes on in AWS, right? It's not on-prem. It may not have all the same notifications you'd have for on-prem stuff, but this stuff's happening, right? This is why we care about it. This is not some ethereal thing, right? So this is the core mantra here. Security is my responsibility in AWS, right? So how is AWS different from on-prem? Like, what are the differences? What are the core things we need to look at? So there's 4 major log sources that I'm going to talk about today. And there's others. There's things for like application load balancing, elastic load balancers, CloudFront if you're hosting websites, blah, blah, blah. But the 4 main essentials are CloudTrail, CloudWatch, config, and S3. And CloudTrail is essentially API activity logs. Almost everything in AWS is an API call that is recorded in these logs. CloudWatch is essentially system performance monitoring. You can also do from a CPU I/O metrics. There's also OS and application logging if you instrument it with the right agent. The config logs are basically resource configuration logs. So what's been configured, how it's been configured over time. and what that looks like over time, how that historically has changed. And S3 is essentially the data storage area for AWS. So these are called buckets. The main things that you put data into in S3 is called buckets. And everything else is essentially an object. And then there's server access logs, which we'll get to a little later in the presentation. So we'll start with CloudTrail. So this logs essentially every API call, every action that's taken your account. Like this is your main log source. You can essentially think of this as the Windows event log or syslog or dmessage, dbus messages for Linux. This is the critical core component of AWS where you're going to get the most bang for your buck, and almost essentially everything is going to be recorded. So what might this help you do? You can figure out who did what, when, where they took place. It has source IP, date, time, region, things like that. Who made these calls, user accounts, things like that. CloudWatch, performance metrics. So you can use this to say, oh, have I seen a CPU spike? Was there a spike at 2 a.m.? Why? We're not operating during that time, that sort of thing. Various high-level metrics from a performance perspective. CloudWatch also has an agent that you can install on each host or instance, as they're referred to in AWS, which will also allow you to do host-level, extract and analyze host-level logs. So CloudWatch itself isn't going to be seeing your Windows event logs, your syslogs, or anything, but if you instrument them with an additional agent, they can be forwarded to CloudWatch for monitoring. Config, again, this is the configuration history for instances. VPC is essentially a VLAN, if you want to think about it that way. EBS volumes are basically the hard drives, and security groups is essentially the firewalls of AWS. So this captures periodic snapshots of config status, of everything's configured this way at this point in time, and then at some period it'll take another. You can also do it manually to do them quicker. And so you can capture snapshots of resources in time, you can diff these, and then you can see kind of over time how things have been changed, right? So this would be super useful, right? If something's changed in your infrastructure, config can be a great resource to look at. S3 is again, the main data storage area in AWS for most of your data and info. And so there's bucket level logging, which is essentially, have you created any of these major buckets to put data into, and they can live in different regions. And there's additional logging. So there's object level logging, and again, everything is an object in S3. So if you ever see S3 and you get a link to something in S3 or it's hosted in S3, you'll see something that looks like a file path, like bucket / this / that, and you're like, okay, so it's kind of like a file system. They're like, no, it's objects. And it's like, but they're files and folders. Like, yeah, they look like folders, but they're essentially objects. And it's like, okay, well, can I do a make dir on the command line and make folders in there? And they're like, no, they're not directories. They're not folders. They're objects. It's like, okay, I get it. They're objects. And then you log into the S3 console, and the high-level objects are displayed as folders. And I'm like, okay, I don't follow you there. But as long as you can get past that, you can kind of understand these a little bit better. And there's server access logs. So there's things that are hosted in there, and then there's also the ability to have server access logs. So if the JSON logs, which is the default format, isn't enough for you for the log level or the bucket level logging or the object level logging, there's also server access logs, which are probably what more people are used to for the HTTP, Apache-like server access logs, which can be super useful. So those are the main log sources that we're talking about today. Again, there's others, but these are kind of the 4 core for this high-level overview of starting incident response in AWS. So what should we monitor in general? I started getting into specifics, and then I realized there's basically an entire presentation I can do on specifics on what to monitor, and so that's probably going to be a follow-on presentation at some point. But for now, this is just kind of a general overview of, okay, here's kind of what things break down to and what you'd want to be looking for and what to monitor. So environment enumeration and recon, like they've got to attackers want to find out what's happening in there, and how do they find out that information, right? And in CloudTrail, these APIs are going to look like, get, things, list things, blah, 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 list permissions, get environment resources, things like that. Resource event data collection, these are going to be same gets, they're going to be describe, list, lookup, that sort of stuff. You want to maybe monitor for resource creation, mod, and deletion, right? Those things are pretty critical. And also log tampering and modification, which we've seen attackers do as well, which can be pretty nasty. So this is kind of a general overview of, if you're looking at CloudTrail logs and you want to know which API should I be monitoring for, this is kind of how they break down into what these prefixes are associated with. So again, I started going down a rabbit hole of I had 7 slides just for these specifics, and it's just going to take too long. So essentially it boils down into the quadfecta of monitoring, right? So you have config, which is the configuration resource history. You have CloudTrail, which is your main resource for all the API calls that happen there. You have CloudWatch, which is system performance and also OS and host level logging. And then you have Lambda. And so Lambda is essentially serverless, run this function, in various programming languages. You can do Python and Node.js or whatever, run these things, as something happens. Be like the catalyst to do something once you see something change, right? So with this quadfecta, this is basically what you're going to be focusing on for doing real-time monitoring and analysis and alerting on stuff. So again, there's tons of services and API calls, but my best advice, just to start at least at this high-level overview, is and this isn't unique to AWS, but know how your systems work. Know what's normal, right? And know what's not normal, right? Read the AWS docs. I spent probably 6 months just reading through the AWS docs. It's some of the best documentation I've ever seen in my life. I mean, absolute kudos to the Amazon team, but it is an absolute bear. There is a ton of material, and as soon as you understand it, they add some new feature, which is great, but you got to be on your toes to keep up with this stuff. So think, play, test, right? There's a lot of stuff that goes on in AWS. As you start getting into the environment and saying, oh, I just did this, I'm going to pull the CloudTrail logs and look and see what happens. There's going to be tons of things that you didn't realize were happening in there, and there's going to be information you expect to find that might not be, right? And there's all sets of nuances of, if you assume a role, then that data used to not be associated with the target account, that used to only be associated with the source account, and blah, blah, blah. Anyways, there's a lot of stuff to go into. But play test, think like the attacker, right? Think knowing my environment, if I came in here and I did X, Y, and Z, how would I detect that, right? So here we are in the setup for success phase, right? Still, we're trying to say, how do we set ourselves up for success? How do we prepare to respond, should something happen, right? And one of the things that I like to have our customers set up is an isolation environment. And this is one of the awesome things about operating in the cloud. And AWS makes it super easy. And what I like to do is have customers create an isolation VPC. And it's basically a VLAN. It's totally segmented off from everything else, and give it a route to the internet, and that's it, right? So then when something happens, you can take a system and place it in this environment and have containment, right? Not so easily done on-prem, but a lot easier done in AWS. There's also this thing called flow logs in AWS, which is basically NetFlow that is enabled by point and click, and it's enabled, which is an absolute godsend in a lot of situations. So if you create an isolation VPC environment, set up flow logs, set it and forget it, just leave it there. It's not gonna take much resources. It's not gonna fill up any sort of space in your S3 bucket. But it's set up there so that when something happens, it's a space where you can put stuff and have containment done. And you're not cutting off network connections. You're not severing anything, right? Pretty awesome resource and capability for AWS. What I also recommend is create responder accounts, and these are separate from your main operating accounts. These are essentially the IR roles that you're going to use to respond to events that don't necessarily have admin access to stuff. The base setup is probably just good to have a read-only admin, so you can at least read data, you can get the logs, you can collect stuff, but not necessarily make changes. Unless you need to. Again, it depends on your environment, but a good base to start is just read-only. And then create a dedicated S3 bucket for all this collected data. So have a lab or acquisition or whatever bucket set up with the appropriate permissions. Say there's 3 responders on your team, you have a responder account. These accounts all have this responder role for read-only access, and you have a bucket that's for investigations. Read-only for these people, no one else can see it. Pretty good setup. And if you call this security groups, is basically the firewall setting. So for these instances and for these accounts, basically allow access only in from where people are coming from. So for us, we work remote, so I know the IP or IPs that I'm usually coming from when I'm doing investigations. So for my instances, I set it up that I allow SSH in, but only from my known IPs, right? You want to lock stuff down, and it's super easy to do this sort of stuff. So highly recommend locking it down to source IPs. You don't want people, brute force attacking your response instances and somehow getting in and, then having admin read access to everything. Like, that's a bad setup, right? So then I recommend also having a couple responder instances. And these are the ones where from where you're going to do your forensic analysis or your investigations, right? So have them up and running, have like 3 or 4 ready to go. Maybe keep them shut down or keep them running, whatever you want to do. They cost when they run. But have them set up and ready to go so that you can SSH directly into them and start pulling data as soon as something happens, right? So create a couple volumes, one for your root data, one for data drive, depending on how large or how much data you're going to deal with. If you like doing stuff locally and you want to pull all the data down locally to the data volume, treat it appropriately. And then add all your favorite tools. Personally, I do most, if not all, my investigations with free open source security tools. So it's rather easy to instrument an instance for me in AWS and with Fedora and the cert forensic repo, and I'm good to go. The problem starts coming when you have, say you want to operate from Windows and you use Encase. Like, it's not trivial to go and set up, Encase instrumented in instances in Amazon with the proper licensing, right? And it's not easy to do that. So if you are going to do that, please spend the time ahead of time. Last thing you want to be doing is trying to spin up an instance, you have a compromise, and you're like, I can't figure out how to attach this physical dongle to an AWS instance, right? So, having set yourself up for success, we can enter the treat yourself phase. Targeted response, right? So we have all this set up, we have the capabilities, we're ready to go. Now we're ready to collect memory and disk images. Amazon does a lot of things really well, and they provide capabilities to do what used to be complicated things super easily. Memory collection is not one of them. It surprises me. There are tools to help you automatedly SSH into instances essentially and load kernel objects for the right kernel and collect it, but it's not pretty, right? So unfortunately, memory collection is going to be not too dissimilar from how you do it on-prem. It can be automated with this managed instances /run command, and that's if these instances are already instrumented with an agent that allows you to do these sort of things. So that's something to think about ahead of time as you're deploying your infrastructure. Do you want to have agents running all these systems so that you can reach thousands of them at once, or are you going to do this manual SSH into them, or if you're using Windows, you're going to be already pinging into them, what have you. A really cool thing though is you can image directly to an S3 bucket. So you don't have to image local to the machine, you don't have to necessarily connect anything unless you are in Windows, and you have to use some sort of third-party tool to map your S3 drive. In Linux, you can just use the AWS CLI tools to image directly to it. Disk image is super easy. No longer do you have to log in or do a DD or anything like that. You literally just right-click on the volume that you care about and do create snapshot, and it creates a bit-for-bit image of the drive. It is absolutely fantastic. Right, so once we've collected images, now we can isolate and move these to the VPC, right? So just to kind of illustrate this, I mean, we're not talking, okay, you have an incident on-prem, okay, where's the system located? Is the user on site? Can we reach them? How are we going to image this machine? Oh, it's a laptop. Do we have to have them come back into the office? Or, oh, it is a desktop and it's down here, okay, bring your write blocker down, we're going to go image it live and make sure we have the tools and instrument it. I mean, you're talking orders of magnitude difference. You're talking like hours and days to response for this on-prem sort of stuff, and you're talking minutes with disk and memory image collection from AWS. And isolation, right? I mean, how hard is it to achieve containment on-prem? It's an absolute nightmare. And here, with the proper setup, you collect the images, you move it into isolation, and by the way, it's still talking to the internet, so you haven't severed internet connections. You're still monitoring what it can do. You can collect IOCs. You have NetFlow logging. You can then take those IOCs, have NetFlow logs to the rest of your network, see if it's happening on the rest of your network, right? Really awesome capabilities here. So aside from the actual system data itself, how do we collect these logs that we talked about, right? So most of these logs are stored in S3. So CloudTrail, the config logs, the CloudWatch logs. So if it's all instrumented correctly, you're logging to a single S3 bucket, and all you're doing is logging in and copying all of the relevant files for the days of interest. So CloudTrail is broken down by day. So you're like, oh, it was March 18th or something. Log in, go to 2017, 316, blah, 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 collect 317, 318. And then it's just a matter of doing the analysis. So when you create a snapshot from a disk image, remember it creates a bit-for-bit image. But then how do you analyze that, right? So you have that sitting somewhere, but now what? Well, remember we created those responder instances, right? We have those up and running. Well, all we need to do is, again, right-click on the snapshot you created, create a volume, right-click, attach to an instance, then image out if you want an actual image to store somewhere or download to your network for storage or chain of custody or whatever you want to do. But it's that simple. I mean, if it's directly attached to your machine, you've made a couple clicks and it's immediately attached and ready for analysis. Like not walking a drive down anywhere, not transferring an image over the network, right? It is immediately available. One thing that is not initially evident that can be a royal pain is that when you first attach an image or a volume created from a snapshot, it may perform at less than 50% of expected performance. And we find ourselves in a conundrum here when we're trying to basically take a DD image, say I attach it and I want to create an image elsewhere for other people to work on or something like that. Because Amazon's advice is, well, their statement is it needs to be initialized, so every block on the volume has to be touched before it can reach its full performance. For whatever reason, whatever they do in the back end, okay. And their recommendation is, well, we recommend FIO or DD on Linux to touch all those blocks and do that, but we're doing DD. So it's kind of a catch-22, right? So be aware that you may have an absolutely fast SSD, highly optimized IOPS volume that you've attached, and it's just giving you crap performance for imaging or accessing it, right? And it will until you've touched all the blocks. Just a pro tip that wasn't evident for a long, long time, but now they actually have it in their docs. And memory analysis isn't dissimilar from traditional on-prem. You can read it directly from S3 or copy it to your local drive for analysis, analyze it like you would any other image. So log analysis options. So we got the disk and the memory. We walked through how to do all those for log analysis, right? So for the manual command line gluttons in a lot of us, or some of us, or maybe very few of us, I don't know how we break down here. Personally, I love it. So for me, it's just a combo of like gunzip, zcat, sift, and JQ. So how many people have heard of JQ? Man, not many. Okay, if you've worked with JSON in any length of time, JQ is your absolute best friend, right? So it can take a JSON blob and intelligently transform it with filter queries, right? So here's kind of an example. Here's kind of a snippet of a log I took from CloudTrail, and this is what it would look like. So here's a stop instance API call. So this is what you'd see in CloudTrail for when someone right-clicks or does from the command line stop instance. So all we're doing is running JQ. You can see you have everything as a record. So it's a record, the first one, identity and username, and boom, we get Alice, right? Or we want to extract the source IP address. And so if there were a bunch of these and a bunch of records, it would be record 1, 2, 3, 4, blah, blah, blah. This is going to be your best friend from the command line for parsing CloudTrail logs. Or assisted analysis, courtesy of AWS, meaning courtesy of your wallet. You can extract into Elasticsearch for analysis. You know, if you have a cluster, you have a Kibana interface, no different. You can use Kinesis to send logs directly to your cluster. That's what some people do. Something came out called Athena relatively recently, I think a couple months ago. So before you used to have to send the data somewhere, take it somewhere out of S3, do something to work on it. But Athena actually allows you to perform SQL queries against data right in S3. No taking it anywhere, no having to copy it off, put it in another tool, nothing. Pretty awesome. So query to your heart's discontent, depending how much you like SQL, but it is limited to a few regions. So what do we look for when we're doing analysis, right? And this is another talk that I think I'll have to give completely separate because there's a lot of specific things to look for. But overall, you know, start with CloudTrail. You know, something happened. Okay, so the one login attack, right? So something happened. Instances were created. Recon was done. They can start looking for who's looking for the identity, right? So there's a thing called like, you know, get the current identity of who I am. Like very few people are going to be doing that. Now some tools do it, so that's where you'll have to separate the wheat from the chaff. But think like an attacker. Like when I get in, I'm like, who am I, right? It's the equivalent of the who am I, right? So like look for the calls that are requesting what identity am I. Look for a lot of successive gets or describes or lists sort of stuff. And with that, you'd be like, okay, I see a username associated with it. or I see a certain role or something that was created, or I have a source IP. Use it. It's a star pattern approach, right? Same DFIR analysis skills, but the CloudTrail is going to be kind of your main source of doing that. CloudWatch, if you had alarms set up for resources, look for any anomalies and spikes. If you had OS host logs instrumented with CloudWatch, check those out. For config, see how things transpired over time chronologically, what happened. If you have a time frame of when you started seeing anomalous activity, well, what was changed and when? Right? This is a great tool to say, oh, this config was changed, or this volume was created or added to this instance, or these instances were set up. Use it to your advantage. Identify anomalies there. And S3, review object accesses, right? So maybe they want to get data out. Maybe they set up another bucket, and that's how they're doing exfil. They made it publicly available, and now they're doing all sorts of stuff. We'll see what buckets were created. What did they get? What did they put there? What did they delete? Right? So that's kind of a high-level overview of everything. I could do a ton more material here. I could talk for days about it. But suffice to say, right, so AWS provides a lot of these native capabilities for performing DFIR, right? I mean, so, I was asked a couple months ago, for our company, like, what is AWS complicated? Like, why should people move to it? And I'm like, I wish everyone would move to it just because I would take a default AWS install any day over a default on-prem install for doing any sort of incident response or forensics. Because by default, CloudTrail logs are enabled, right? You can see what's going on in the infrastructure. Like, for any of us that are consultants or even in your own company, like, how often does something happen and you're like, oh, we never got that set up, or that wasn't enabled, or those logs weren't enabled, sorry, we didn't get around to it, right? It can be a nightmare, right? But there is a non-trivial ramp up. Like I said, it's easy to spend 6 months down the docks getting to know everything really well. But at a certain point, the DFIR methodologies for AWS and on-premises converge, right? So there's these different logging sources and blah, blah, blah. Once you get the data out, and once you have the instances set up and you're doing analysis, nothing changes. You still have logs, you still have disk images, you still have memory images, right? So there is an initial ramp up that's different, but at some point they converge and you're just being your regular DFIR rockstar self after a while. So what do we maybe learn? Maybe we learned a couple new words. I don't know. Maybe you already knew those words. But like I said, there's a couple more presentations I think that are coming out of this, and I didn't realize it until I started putting all this together because there's a ton of, I think, really useful material for everyone. But hopefully this just kind of whets our appetite and kind of gives you an idea into why we care about it, what's going on, how super useful this can be, whether you're on the fence of moving in or not, or you're already in there and you just want to figure out, how do I know if an attacker is using my infrastructure right now? Because I never really looked. Maybe this is the time to start looking. If you have a $60,000 a month bill, it's going to be really hard to identify that $1,000 of that was like because an attacker spun up an instance and started moving data around, right? Like, these are the things to start thinking about and why we should care, because this stuff's happening, right?